Welcome all. This is 1 point, this is 1 point. Suppose this is 0 and this is 5. You deposit some amount here, 150, to how much it will grow. What should be your answer?
E power 150.
E power
150.
1 plus t,
150, sir.
1 plus t. What is t here? Okay, no problem. I didn't ask about t. I just asked if you deposit how much it will grow.
150 into 1 plus I whole power 5.
Where 1 plus t comes here.
1 plus I, sir.
Okay, 1 plus I power.
5. 150 into 1 plus I power 5.
This is 150, okay?
Yes, sir.
So are you saying 150? This one you are saying?
Yes, sir.
Okay, this is correct. Any other expression you know for this? So what? You will write this? I am a 12th class pass student, or I am a girl, or you can say I want to join BSc Data Science online in Madras University. They've launched a course this time. So I have so many use, right? One type you said. Do you have any other use? You can say any other expression. Yes, try. There are so many expressions you can count. Okay. So you just tell me another one.
1 plus I 1 by 5 by 1 by 5.
Why 1 by 5?
5 years.
5?
Interest rate will be for 5 years.
No. 1 by 5 by 1 by 5 you can write. Then what will be the power?
1 by 5.
Okay, this you are saying. In that case, there will be no power. Because this is 5-year interest rate, right?
Yes, sir.
You are saying this only?
Yes, sir.
Yeah, this is correct. So there are so many expressions. You tell me any other one. Here you used 1-year interest rate. Here you used 5-year interest rate. So one period. One period is 5 years. Can you imagine it's a very big 5-year period? Normally we deal with 1-year period. Here you have taken 5-year period. This is correct anyway. Now tell me another expression. Take in half years. Can you take in half years?
Yes, sir.
So if you take in half years, it will be I2 by 2. How many such periods are there?
2.5.
No, not 2.5.
Half year.
Half year. How many half years are there in 5 years?
10.
10. Okay. All right. So if I make it n, suppose you write 0 here, n here, you deposit 1. Okay. Instead of n, let me write 1. 1 if you deposit, it grows to 1 plus I power n. Or maybe we can take a number like 2. You have another expression, 1 plus I2 by 2 power. How many half years are there?
4.
Okay. You can continue this way. You tell me using seconds. 1 plus.
1 plus
How many seconds are there in 2 years?
2 into
Okay, let me
five.
make it 1 year only. Yeah, tell me now. 1 year. 1 year means power is 1. 2 half years. Now tell me in 1 year how many seconds are there?
365 into 24 into 60 into 60.
Divided by?
Same 365 into 24 into 60 into 60.
Is it over?
Whole power.
Yes. Power? Again, because I2 by 2 power 2, because one period is 1 second. Okay. After every second, suppose you deposit money for 1 year, after every second you earn interest. And the interest is there, it's reinvested, and finally after 1 year, bank will give you money. Suppose you need to get after 1 second, you deposit money, give in one end, receive in other hand. That's 1 second. You will get some interest. If you have 1 crore, maybe you will get 10-20 rupees in 1 second. So using 1 second interest rate, how many seconds are there?
365 into 24 into 60 into 60.
Okay. So this looks big, right?
Yes, sir.
Even if I go to half a second or maybe 1000 of a second, again it will increase. So what will happen is there is a limiting value. We say, suppose instead of 1 second, you make it half second, millisecond, then continuous, you make it continuous from here to here. That means company is giving interest continuously whatever you deposit. Suppose 1 lakh you deposit, company will compound your money continuously. There is no gap. This is once in a year, then half year in a year, then every second, then now continuously your money is subjected to the interest rate. Then how much it will be? There is a derivation that was there prior to 2012. After that, they deleted. So you need to remember a formula, that's all. E power delta, where delta is called force of interest. So you find this one or you find this one, they're the same. 1 plus I is e power delta. So you can use this formula, you can use this formula, you can use this formula, you can use this formula. It depends. If this is given in the question, you have to use this formula. If this is given, you have to use this formula. If I is given, you can use this formula. If delta is given, you can use this formula. However, even if I2 is given, you can use any of the formulas because there is a link between I2 to I, then I to delta. You can link and you can find corresponding delta, or you can any formula you can use. But it's easier if you do it whatever way it's given. You can save a lot of time. Now, this is the formula. Derivation is not required. It's not there in your course. Just remember, if you deposit 1, it will grow to e power delta, where delta is called force of interest. Delta is force of interest, okay? So using force of interest also you can find. So if you want to know what is force of interest, that is equivalent of this one. So it's like this: I 1 year nominal, I2 half year nominal before conversion, I 365, like that it will go on increasing. The nominal I'm saying before conversion. So now what will happen if this is very large? This is very large, okay? IP, when P is very large, that is delta, that's all. So mathematically we write this way: when P is very large, this will be equal to delta. This is the definition. When P will be very large, then IP will be equal to delta. Even this will be very close to delta. You can find, if you take I 10%, I2 will be 9.8876%. That way you count. You count this one, you count this one, delta. How can you count delta? They are equal. Because after 1 year, there are two expressions. Even all are equal. 1 plus I is e power delta. So if you find delta here, ln log base c, 1 plus I. Use a calculator, find this delta. Delta will be close to this value. This value is close to delta, that's all. This is 1 second, this is 1 moment. This is 1 second interest rate, nominal interest rate convertible to every second. This is convertible to every moment. That is force of interest, okay? Now, how can you use this one? Any doubt by now?
No, sir.
Okay.
No, sir.
Okay. Now let's go beyond 1 year. The way we wrote 1 plus I square. So we'll write this square, that will be E2 delta. Then after n time periods, it will be e power n delta. So delta will be given. Suppose one example is given. Acha, I have to say something here. Now, giving continuous interest means what? Practically, it's not implemented in any bank, but then in higher actuarial subjects and otherwise also we use this one. But direct application in the banking system has not been done by now. Though some banks in US, they are trying to implement this one, this is not implemented. But you have to know the meaning. Suppose money is compounded every year, there is a meaning. Money is compounded every half year, there is a meaning. Money is compounded every day, there is a meaning. Money is compounded every moment. That means every moment you are increasing something. Can you give any other example apart from finance? You have to give a continuous example. Okay, suppose you drive. When you are driving continuously. You are not driving discretely. Every half every half minute or every minute you drive and stop, not like that. When you drink water, it's not discretely, it's continuously. It's not that you drink water, then you stop for a second, another sip, stop for a second, not like that. You drink continuously, normally. I mean, maybe some drink very slowly, that's a separate thing, but continuously. So this is a continuous thing. Continuously, suppose you deposit 100 rupees, continuously they will give you some, they will add some amount in 100. But if you ask what is, that's a very, 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 very small amount, we can say. That's a very small. But when they will add continuously some amount to your 100, after 1 year, if you go, it will increase to, suppose I is 10%, according to that, delta is whatever, 9.53%. So on 100, you will get around 10 paisa extra, 9.53 paisa extra. You calculate delta for I 10%, that will be 9.53%. So 100 into e power delta, when you multiply, that will be 109.53. You can check it. If delta is 9.53%. Okay. So your money will grow. Your money will grow. The bank will grow your money. Now, how it will grow? Every moment it's fine, but every moment it will grow equally, or it will grow, at a higher speed from time to time, or lower speed. What do you think? If you calculate every second you check, it will grow equal amounts, or it will go, I mean, the growth will increase from time to time. You see, COVID situation, initially the COVID cases were 1,000 a day, then it increased to 2,000 a day, then it increased to 20,000 a day, now 50,000, 52,000 average now. Patients are, I mean, India getting, okay, 52,000 COVID patients each day. COVID positive cases, you can say. So it's increasing. Every day it's increasing, it's not constant. And once it will reach the peak, it will decrease. Every day, the number of corona patient cases will decrease. But it's a discrete thing anyway. We calculate uh, every daily basis. You can calculate hourly also. That's a separate thing. When you drive, suppose you want to drive 3 hours, 100 kilometers, how you drive? You drive at a continuous speed or variable speed?
Uh, According to the traffic or the road
Yes, normally
conditions.
practically it's not constant, right?
Yes, sir.
Because there will be some kind of traffic everywhere. Even if there is no traffic, the road is not that smooth. If you see the road somewhere, there will be ups, somewhere there will be down. So it's not the way we think. So what will happen is, you can say that you will be able to travel at a constant speed. It's not possible. There are frictions, right? So because there are frictions, what will happen is, you travel at a variable speed. But here delta means it's constant, constantly at each point. It's growing. Your money is growing constantly at each point. Okay, like every moment, you can say. Now suppose you drive at a variable speed, sometimes increase, sometimes decrease. Then what will happen is, with the time t, your interest rate will change. For that, delta t we write, that is force of interest. This is constant force of interest. For example, suppose this is oil here, okay, and you give heat here, oil, okay. Now, kacha papad, pakka papad, what you say? You can use here, okay. Then what will happen? Because this is the oil, it's hot, this papad will grow in hot oil. What do you think? It will grow at a constant speed or variable speed?
Uh, According to the heat given to the oil.
Normally, when you see someone is cooking, it's growing at a variable speed or constant speed?
Constant speed.
Not constant. It grows at a variable speed. That's what I feel. Because if you see the watch, suppose in 1 second you see, the next second you see, they are not same. It increases very
Yes.
rapidly. Even if you are here on a tree, okay, and you drop a fruit from here, okay, then what will happen is, if you see the distance covered from time to time, every second, it increases. That's how it's not linear, it's not constant. That's what we say. Gravitational force is not linear. Linear means it's constant. It from time to time it increases normally. Even when you go by flight, when it takes off, it increases speed to go to the highest position. Sometimes it decreases also. When we go by car, sometimes it increases, sometimes it decreases. Delta we use for constant force of interest. Delta T for variable force of interest. Two formulas you need to remember. Even this is a derived formula. This is a particular case. The normal formula derived is delta T. It's like Vt, velocity. Whatever way you use velocity, if you have not done science, it's okay. You can use delta T. Now, the formula is this. If you deposit money here and the time period is n, 1 you deposit, this is E delta. If you deposit 1 here, this will be E power 0 to n delta T dt. This is the formula, derived formula. You have to integrate. You are not integrating, you are integrating only delta T, then E power we are writing, that's all. And you see, this is a particular case of this. You can verify that. Just so if you integrate this one, dt integration t n minus 0, n will come here. N years. So sorry, I forgot to write n. So this is for n years. If you write for 1 year, this will be delta, this will be 1, this will be 1, this will be 1. So now remember this formula. Suppose this is 0, even I can write A here, B here. You deposit amount right here, integrate between A to B delta T dt. This is the final formula. Again, we'll see the use in annuity everywhere. Today, I'm concentrating only for the first chapter. Okay. Suppose, let me write one example. You write here 0 or maybe 5, 10 here, and delta T is given, suppose 0.08 plus 0.001 T. You know the meaning of this? Logically, what is the meaning of this? This means actually, if I take instead 0 to 10, you put 0 here, the interest rate here you will get nominal. If you put 0, T0, that is 0.08. So it's operating at 8% at this point. If you go to the next point, every point you can find, you find at 1. You put 1 here. If you put 1 here, that is 0.081, that is 81%, 8.1%. So it's increasing. That way, if you go to 10, this will be 9%. So from 8% to 9%, it's growing. However, if I write 8% or 7%, I can write like this. So this term gives you the variability, whether it will increase or decrease. If you write a minus here, it will decrease. If you write t square, it will increase more from time to time. Growth will be more. So there are so many variations you can write. Sometimes it will increase, sometimes it will decrease. I can write a formula in such a way. So there are so many ways you get delta t. You just need to integrate this one between these two limits. That's all. And the amount you need to write. Let me do it. This one will keep. And the points I can give 5 to 10. You deposit 350 and find the value here. So we'll write the formula 350 into e power here 5 to 10, 5 to 10 delta t dt. So now if you find 5 to 10 delta t dt, this expression, that will be 5 to 10 delta t, you write 0.08 plus 0.001 t dt. Then this will be 5 to 10. See, we are not integrating e. 0. Okay, sorry. We'll integrate. This is constant 0.08 dt integration t plus 0.001 t square divided by 2, then 5 to 10. You first put 10 in t, then put 5 in t, subtract. Whatever value you get, you write here, that's all. Answer will be 350 into e power a. See, e is here, there is no integration sign. Integration sign here in the exponent. So you find this separately and write the value here. Then use calculator find the value of 3 power a, whatever it is, you write here, multiply, you will get the answer. And this formula you will be using in 10 to 20 problems, whatever problems you will have, with a slide modification. You have any doubt? You think why you wanted to discuss this one? So if you have any specific doubt, you can ask. Otherwise, you do the problems. From next time, you can ask me doubts. Okay? Or
Yes,
if
sir.
you have any doubt, you can ask me now.
I mean, in annuity problems, the force of interest is different. I
Not
mean,
different.
this
Don't
one I
see. I'll
can.
tell you. Let's go to annuity now. In annuity problem, suppose, yeah, there are certain places. We'll go to that later. Suppose here one, here one, here one, here one, here one, and you want to know the present value or future value, whatever you are finding. So this one, when you deposit, they will increase this one continuously. Instead of 4 times, 1, 2, 3, 4 times, they will give you interest continuously. Here also they will give you continuously with a constant force of interest or variable. That's a separate thing. Continuously here, continuously here, continuously here. Then what you will get? That is the question. So you can just use, if it's delta, if delta is constant, then always you can use that formula. Okay. So that's something you can use always. For 5 year you can use, for 4 year you can use, 3 year, 2 year you can use. That's a normal case. Okay. If a problem comes, you can do this way. Now suppose you have a long year annuity and the question is this: 0, 1, 2. Normally you get this type. What happens is, here 1 per annum, 1 like this per n years, then half per half year, then 1 by 4 every quarter, 1 by 4 every quarter, total 1 in a year. Suppose 1 by 4 every quarter. What will be the present value for 3 years? Tell me. Suppose somebody will pay you, somebody says, okay, you join our job in our company, we'll pay you 1 by 4 lakhs, that means 25,000 every quarter, because you are doing graduation. So you are a kid, so we'll pay you kids pay. Kids payments, it's very less, right? 12th class student, they are working in McD's, they are getting 10,000 per month. So 25% every quarter. Okay, so first quarter 1 by 4 lakhs. In lakhs, I'm saying 1 by 4, then 1 by 4, 1 by 4. That way you can continue. So what should be the present value here?
In
Notation.
annuity, sir,
Yeah, annuity notation.
1 lakh into a 3 a 4.
Yes, correct. So it's like this. First is AN or A3, suppose this one. A3 means this one, 1, 0, 1, 2, 3. Okay, let's not make it clumsy. This is for 3 years, and the payments are yearly, 1, 1, 1. Here it's A3. Then we have taken less frequently, quarterly, but we decrease the payment. If you make it 1, 1, then it will be 4A3. We made it 1 by 4 so that it's 1A3. That's fine. Now you make daily payments, 1 by 365, 1 by 365, that way. Then this will be A365, right? And we have to write 4 here, 4 times. Here, 4 times a year for 3 years. Sorry, I have to change it. Here, remember, 4 times a year for 3 years. 3 years, that will remain the constant. You can change it to n. So from 4 times, we'll make it 365 times. Okay, that means here daily payments, you can say. The daily wage workers, they're getting. Here quarterly payments, you decrease it, and then you write, you make it every second payment. Then make it continuous. Every second means it will be 365, the present value, okay, of so many payments every second. You calculate how many number of payments are there. You can use a calculator. That value will be 60, 24 into 24, you know. Now, instead of writing a big one here, what you can do is you just replace it by delta. Okay, so bar we write here. Instead of writing a big number, if P is very large, if P is very large, 365 into 60 into 24 into 24, sorry, into 24 into 60 into 60, then make it half second, quarter. Then when P is very large, 10, 50,000, 1 crore like that, you need not write a big one here. In expression, you will have a lot of things you need to calculate. You can replace it by AN bar. Remember, AN bar should be equal to here A3, if you find A3 bar using the formula, AN bar formula is 1 minus BN by delta. Delta comes here. So this A3 bar is approximately equal to A3 365. Okay. So daily payments when you are making every moment payment, there will be a little difference. Even you make it very high, 365, 24, 60, 60, every second, millisecond, every fraction of a second, the more bigger you take, the more closer will be to this one. The limiting value is, I can write like this, mathematically, ANP, when P is large, that will be AN bar. Okay. So AN bar formula is there, it's derived, you have to use this one, that's all. So now my question to you is, don't you think paying daily or maybe paying hourly, paying half yearly, paying yearly, things should change? Why they are approximately equal? We're decreasing, right? See, 1 per annum, 1 by 4 per quarter, we are decreasing payments. It's not that we are giving same payments. If you pay 1 per quarter, it will be more. Here, you are giving 1 by 365 every day. Then if you make it every hour, second, the amounts will be less. Okay. The total amount should be 1 in a year. That's all. So the new formula is AN bar. AN bar formula. This formula only you are supposed to use. This is for logical understanding. Okay. But this is the only formula you have to use. Now you come with doubts. Directly you write on WhatsApp, or instead of writing on WhatsApp, if you have a lot of doubts, you can join for a class. Wherever you have doubts, you can ask me. Okay.
Yes, sir.
Sir,
Now, yeah, tell me.
so what is accumulation factor?
Accumulation factor, it's a notation. Okay. It's not required. But yeah, if you want to know, accumulation factor means, suppose you you are finding from 0 to 5, you deposit in any amount 350. Okay, so what we write is 350 A05. This is a notation we are using, that's all. A0 to 5 means accumulation of 1. If you deposit 1 here, then it will grow to A05. That's all. This is a notation. A05 is a notation. Sometimes you write A5 also, 0 to T, AT also. Remember, normally A05 means at 0 you deposit 1. Whatever you get at 5, the notation is A5. This is called accumulation factor.
So then what's the relation between accumulation factor and force of interest?
No relation. You can write, suppose I is given, I can write this also, 1 plus I power 5. If I, because if you deposit 1, it grows to 1 plus I power 5. This is a new notation now. If you want to use I2 by 2, you can write I2 by 2 power 10. Normally, they must have used in force of interest. That's a separate thing. There is no link. This is a notation. Even when I wrote 350, I had to multiply by 350, because 1, if you deposit 1, then you get 805. Whatever you get answer, that notation is 805. So if you are using delta, e power 5 delta you need to write. If you are using variable delta, e power 0 to 5 delta t dt you have to write. So all are for this. Accumulation factor has a different meaning. It has no link with any interest rate. Whatever expression you want, you can write. But
Okay, sir.
normally we don't use for these things. For these things we use. Even if you don't use also, it's fine.
Okay,
Okay.
sir.
Yeah.